And good afternoon to Prof. Kamarazaman and Dr. Razi. Today I will present about project air conditioning. My name is Mohamad Syahiran and my friend Muhd Harith and Mohamad Faiz. First, we will introduce about air conditioning. Air conditioning is device that will control the air inside a closed space. Air conditioning is the process of removing heat from a confined space, thus cooling the air and removing humidity. Air conditioning can be used in both domestic and commercial environment. This process is used to achieve a more comfortable interior environment, typically for human. There are some main components for air conditioning system, which is compressor, condenser device parameter, and evaporator. Uh, From this project, we were given a task to design a suitable central air conditioning system by carrying out all the related analysis on the condition for air in the surrounding. In this case, we will design the air conditioning for 3-story building that occupy for at least 100% inside it. Normally, the design for the air conditioner is just using the rule of thumb, which is if the engineer do not follow the specification to install the air conditioner inside the building. By following the ASHRAE standard, we can minimize the cost for installation the air conditioner inside the building. The specification of the air conditioner, such as the ducting size, must be sufficient to accommodate the cooling load that has inside the building. If the ducting size is too large, it will increase the cost for installation. To ensure that we get the good quality design for the air conditioning, we should consider all the air conditioning aspects such as ducting size, design of chiller system, estimation of cooling load, and cost estimation for the air conditioner. For objective, this project is to design an air conditioning system for a 3-story building by applying the basic principle of air conditioning design. Next, to design air conditioning system that have lower maintenance cost by choosing suitable size of ducting and type of air conditioner. Surrounding condition at 3 pm based on psychometric chart. At outdoor, the dry bulb temperature is 37, while room is 34. Thus, the difference of these two conditions is 30 degrees Celsius. While the relative humidity difference is 20 degrees Celsius. The relative humidity and dry bulb temperature we can refer on psychometric chart. This is a design for ground floor. For ground floor, we have a cafe, prayer room, toilet, and conference room. And this is for first, second, and third floor. For first, second, and third floor, we have CEO room, prayer room, toilet room, manager room, restroom, store room, and pantry. Next, I will explain about cooling load calculation. The objective of cooling load calculation is to calculate the cooling load needed to remove the amount of heat energy from an office building to maintain designated temperature by the HVAC equipment. For ground floor, the total number of rooms is 4 units, total number of people is 24%, total length 40 units, and the dimension for this floor is 30 plus times 30 meter. Okay, this is summary for sustainable and latent heat gain for ground floor. The highest solar heat gain for sensible heat is at wall, which is 16,141.34 watt, while the highest latent heat is infiltration, which is 5,998. For first, second, and third floor, the total number of room is 11 unit, total number of people is 27%, total length 40 unit, and this dimension 30 plus 30 meter. Um, this is summary for first, second, and third floor. The total sensible heat for first, second, and third floor is 24,053.3, while the total latent heat is 7,300.2. The function of ducting is to channel or direct the air to place where the conditional air is needed. So, for the ducting design for this office, ductwork must design and install correctly because the ductwork can influence our utility bills. A good installation job will result in good performance. Factor that can undermine heating and cooling efficiency is the duct leaks, poor return system. Another important factor in the installation process is to make sure that the ductwork is sized properly. Oversizing system will cost more and does not maintain the desired airflow. A complete ducting system contains many other components, such as vibration isolators, take-offs, stack boots and heads, volume control and dampers. Ducts are classified based on the load on duct due to air pressure and turbulence. So this is the characteristic for pressure and for velocity. High velocities in the duct results in smaller ducts and hence lower initial cost and lower space requirement. Higher pressure drop and hence larger fan power consumption. Increased noise and hence a need for noise attenuation. So for the floor duct sizing, this is the summary table we made for the ground floor and the other floor, first, second and third floor. So we need to know the floor duct sizing that is suitable for our office to get the desired air flows. From the table above, we can calculate and find the ducting size for each floor for the building. So we can know the area of the rectangular duct for ground floor and the first and second, third floor. So this is the calculated air handling unit for each floor. For the ground floor, the grand total heat is 31,353 watt, while the first, second and third floor, the grand total heat is 86,667 watt. So we can see here, this is the plan layout for routing of the ducting system of the office building. This is for the ground floor. And this is for the first, second and third floor. It is the same for every floor. For the chiller system designed for this office building, we decided to choose the model LSBLG 350MC to meet the load produced by the office building. The total cooling load generated by the building is 291,356 watt. This model comes with the cooling capacity around 351 kilowatt, which is about 99.8 refrigerant ton. So for the cost estimation part, it consists of two parts, which is one is the installation cost and another one is the operating cost. So for installation cost, this cost is considered a fixed cost of the associated batch, so its cost is spread over the number of units produced. For operational cost, the routine cost of a running business. So this is the installation cost for our initial cost for the office building. So the total initial cost is around 140,360 ringgit. So for the operating cost of the chiller, we got the total electric consumption per day around 750 kilowatt hour. And for the air handling unit, we got the total electric consumption per day around 405 kilowatt hour. So the total operating cost for both air handling unit and the chiller are around 13,346 ringgit per month. So for the 1.5 horsepower air conditioning unit, we got the total electric consumption per day around 1,200 kilowatt hour for 89 units of air conditioner. For total operating cost per month of this air conditioner, we got around 17,007 ringgit based on the tariff from the TNB.
Finally, as a conclusion, we have calculated the total cooling load based on cooling load on each respective floor. The total cooling load is 291,356.15 watt. By referring to an air conditioning company such as Mitsubishi Electric, we have chosen the most suitable air handling unit, which is the AHU, referring to the grand total heat calculated on each respective floor. The centralized air conditioning system has been chosen for installation. This is because the office building can save up their expenses for operation costs compared to using split unit air conditioning system. Total installation cost for every part of the chiller system is around Rm 140,360, while total operating cost per month is 13,346.4. For the split unit, the operating cost per month is Rm 17,007 ringgit. Thus, by install chiller system on this building can reduce cost per month for the air conditioning system. That's all from us. Thank you.